All right. So this here happens to be a bit of an addendum to the video lesson that I just did here. We just proved that the centroid divides each median into a 2-to-1 ratio here. Now we did that analytically. Now I'm actually going to prove this in a slightly different fashion here using a different concept, but it works out just as fine here. So I'm going to have my triangle like this here. And this, what I'm going to do is I'm going to draw BE like this here. So let BE be here be a median. So I'm going to set it up so that AE and EC are congruent here. Now note that in this case here, when you look at this triangle, in this sort of setup here, it should not be too hard to show that these two sub-triangles here should have exactly the same area. Now if you don't believe me, consider the following here. Notice that the area of a triangle is just 1/2 the base times the height. These two triangles have B as their highest point, so they both have the same height here, right? The height being sort of this red segment like this here, right? This red segment here is our height, right? They're both triangle ABE and triangle BCE are that tall. And note they have exactly the same base. Even if the bases are different segments, we know that from the fact that BE is a median here, AE and EC are congruent, and therefore they have the same length. So they have the same base here as well. Base here. So that means it makes sense here, since the bases are the same, the heights are the same, the areas are the same as well. So what we have here, therefore, is the fact that, and again, remember, if you put square brackets around the name of an object here, that's just the area of that object. So ABE should be equal to CBE here, right? So that is going to be an important thing like so. So this is going to be an important thing. Note that whenever we draw any median in any triangle here, it divides the triangle into two triangles of equal area here. They may not be congruent, but of equal area. Now, let's actually get to the thing here. So the actual proof is going to look something like this here. I'm going to call this point here D, I'm going to call this here F, and again, these are midpoints here. So BD and DC and BF and FA here. I'm going to go ahead and sketch those out here. Okay. And then we're going to sketch this. Okay. There we are. You'll note that by drawing in all the medians here, we're going to call this point here the G, the centroid G. By drawing in all these medians here, we have 6 triangles here. So note that in this situation, if we look at G, by the same token we did earlier here, GAC, we have that same sort of situation. They have the same height here, which is the distance from G to AC here, and they have bases that are equal to one another. So in this case here, we can do the same thing and call these both having the same area. So I'm going to call this areas here X. These triangles AGE and EGC have the same area, call it X. We can do the same thing over here. These both have the same area as well. I'm going to call them Y. And by the same token, these are the same area as Z here. Okay, so that's going to be really important. So now we note that in this situation, we have our 6 triangles. And based on what we talked about before, the 6 triangles have areas, and they're actually split into 3 pairs, 2 X's, 2 Y's, and 2 Z's. But wait, let's go back to what we did here at the beginning. We showed that ABE and CBE have the same area here. That's what we showed at the beginning. But if we take a look at triangle ABE has 2 Z's and an X. So therefore, the area of triangle ABE is just X plus 2Z here. Similarly, CBE here is composed of 2 Y's and an X, right? Therefore, 2X plus 2Z is equal to X plus 2Y. Well, wait a minute. If I subtract X from both sides, this goes away. We're left with 2Z equals 2Y here, and then we divide everything by 2. This goes away as well. And we're left with the fact that Z is equal to Y. But wait a minute. If Z is equal to Y, then this is the case here. And by the way, note that we just did this with these 2 triangles here. I could have done this with these 2 triangles, ADC and ADB here. I could have done exactly the same thing. I get 2Z plus Y is equal to 2X plus Y, and that shows X is equal to Z. So in fact, with this, you can actually show that X and Y and Z are all exactly the same here. So as a result, what we have here, ladies and gentlemen, is that these 6 triangles all have equal area, and that's really important. They all have equal area. That's going to be really, really important here, because now we can actually get to our we can actually finish here. So now if we take a look at this, right? Now let's take a look here at how the triangle works like this. So now I'm gonna flip the triangle so that it looks like this here. So we focus on this, right? Just focus on, let me do this here, I'm sorry. So here's triangle ABE. X, Z, and Z are all the same here. Notice that we can set BE as the length. Notice that both of these here is the height. So both these triangles here have exactly the same height from A to BE here. But wait a minute. Note that here, this triangle AEG has that height. So I'm going to draw this height in here. I'm going to call this H. This height here, H, or I'll call it H2, sorry. This height here, H2, is the height for triangle AGE and the height for triangle AGB here. But wait a minute. They have the same height. Now note that triangle AGE and AGB have, AGE has half the ratio of AGB, right? Or in other words, AGB is double the area of triangle AGE. But the heights are the same, and this triangle has double the area of this triangle. Where does 2 to 1 come from? That 2 to 1 ratio only has to happen, therefore, in the bases here. So therefore, because of this fact, we know that BG and GE have to be in a 2 to 1 ratio. So we can do that here. But of course, we can always spin the triangle and do it for any other pair, right? Or I can do it for this particular, I can do it for this one here, do the same thing. Or I can do it for this one here and do the same thing. So therefore, those also divide into a 2 to 1 ratio, but this time we proved it using areas.